title of our discussion today is The Relevance of Statistics in Decision Making. Introduction and Abstract. Statistics are fundamental to the process of decision making across virtually all disciplines. They provide the essential quantitative foundation for the collection, organization, analysis, and interpretation of data, enabling individuals and institutions to make informed and rational choices. In a modern society increasingly driven by data and technology, statistical knowledge has become indispensable for transforming raw information into meaningful insights that support logical, objective, and evidence-based decision-making. By applying statistical principles, decision makers can effectively reduce uncertainty, identify patterns and relationships, forecast potential outcomes, and evaluate the impact of their actions in a systematic and empirical manner. Definition and nature of statistics. Statistics is more than just numbers. It is a science of interpreting data, identifying patterns, and drawing meaningful conclusions that guide rational decision making. To start, we define statistics as a scientific discipline that involves the collection, organization, analysis, interpretation, and presentation of data. It provides a structured approach to converting numerical facts and observations into meaningful conclusions. The discipline is divided into two major branches. First is descriptive statistics. This is the branch that summarizes and describes data using measures like the mean, median, mode, and graphical representation. This helps us clearly understand the current situation. As you can see here in our PPT, descriptive statistics summarizes and organizes data, shows results using graphs or charts, describes what is happening right now, no prediction, just pure observation. While inferential statistics involves making predictions, generalization, and inferences about a population based on a sample. As you can see here in our presentation, inferential statistics makes predictions from samples, uses probability to draw conclusions, generalizes results to a population, and helps plan or forecast decisions. Both branches are essential in decision making because they help individuals and organizations understand existing conditions and forecast possible future scenarios. Through these tools, statistics converts raw data into knowledge that supports sound and effective decision making. The role of statistics in decision making. The central role of statistics in decision making lies in providing a quantitative and objective foundation for analyzing choices. Statistics allow decision makers to interpret complex information, reduce uncertainty, and compare multiple alternatives. Without statistical tools, decision would rely heavily on guesswork, personal bias, or incomplete evidence. Key functions. First is clarifying problems. Statistical data identifies trends and root causes. Second, comparing alternatives. Objective measures help evaluate competing options. Third is quantifying risk. Probability analysis determines the likelihood of success or failure. Fourth, and the last one, is monitoring outcomes. Statistical evaluation ensures decisions achieve intended goals. As you can see here on our next slide, example 1, sales trend analysis. A company reviewing its performance can use sales data to forecast future demands. On their first year, 2021, their sales is $500, while in their second year, 2022, was $700. In their third year is $900, and in 2024, their sales is around $1,200. This data, visualized in Graph 1, Sales Trend Analysis, shows a steady upward trend in sales from 2021 to 2024, indicating sustained growth. Managers can decide to increase their production, expand marketing, or invest in logistics based on this clear pattern. On our next slide, applications of statistics in different fields. First, Business and economics. In business and economics, statistics play a crucial role in decision-making processes such as market analysis, financial forecasting, and performance evaluation. Companies use statistical tools to determine customer preferences, assess product performance, and optimize operations. Economists analyze statistical data to interpret economic trends, inflation rates, and employment figures, which help governments and organizations to plan for a sustainable growth. Second, healthcare and medicine. Statistics are essential in healthcare for improving medical research, diagnosis, and treatment outcomes. Statistical studies help in testing the effectiveness of new drugs, evaluating patients' recovery rates, and monitoring public health trends. For example, during disease outbreaks, statistical models are used to predict infection rates and assess the impact of interventions. Without statistical evidence, healthcare decisions would rely on anecdotal experience rather than scientific proof. Third is education. Educational institutions use statistics to assess students' performance, evaluate teaching methods, and improve learning outcomes. Data from standardized tests, attendance records, and surveys are analyzed to identify patterns and implement evidence-based improvements in curriculums and instructions. Educational researchers also rely on statistics to test new teaching strategies and determine their effectiveness. Fourth, environmental and social sciences. In environmental research, statistics are used to track climate change, measure pollution levels, and assess ecological impacts. Social scientists also employ statistical analysis to study human behavior, social trends, and cultural patterns. Through statistic data, research can uncover correlation and causal relationships that inform policy and promote sustainable development. Fifth, everyday life. Individuals unconsciously use statistics in daily life. When comparing products ratings, budgeting expenses, or evaluating risk in financial decision, understanding probability, averages, and variability helps make more rational personal choices. And lastly, government and public policy. Statistics provide governments with the information necessary for policymaking, planning, and evaluation. National census, labor force surveys, and economic reports are examples of statistical tools that help policymakers understand populations, demographic, social needs, and economic conditions. This data-driven approach allows governments to allocate resources effectively, design social programs, and measure their success over time. Advantages of using statistics in decision-making. Statistics offer several advantages that make them indispensable in decision-making processes. First, reduces uncertainty by quantifying risk and probability. Second, promotes objectivity by relying on data instead of assumptions. Third, improves accuracy and efficiency in evaluating outcomes. Fourth, supports forecasting for better planning and strategy for development. Fifth, it encourages accountability by making decisions transparent and measurable. By relying on statistical evidence, decision makers can justify their choices with data, enhancing credibility and trust in the process. Challenges and ethical considerations. Despite its advantages, statistics are not without challenges. Misinterpretation of data, biased sampling, and incorrect use of statistical methods can lead to misleading conclusions. Furthermore, data manipulation or selective reporting may distort the truth for personal and intentional gain. Ethical considerations such as privacy, informed consent, and the responsible use of data are critical when applying statistics to decision making. Statistical literacy, understanding how to correctly analyze and interpret data, is therefore essential to prevent misuse and ensure accurate, ethical decisions. Theoretical framework. Decision making, whether in business, government, or daily life requires a logical process supported by evidence. The data-driven decision-making, DDDM framework, serves as a theoretical foundation for understanding how statistics guide rational decisions. This framework emphasizes the systematic use of data collected, analyzed, and interpreted statistically to inform actions and evaluate results. It bridges the gap between intuition and evidence, ensuring that choices are not based merely on assumptions but on measurable facts. The DDDM framework is built on 5 interconnected stages. Each represents a crucial step in transforming raw data into meaningful insight that supports decision making. On our next slide, we can see the 5 interconnected stages. Stage 1, data collection, means gathering reliable information. The first stage involves gathering accurate and relevant information about the issue or the problem. Data may come from surveys, observation, experiments, or existing records. On stage 2, data organization means structuring information for analysis. After the data are collected, they must be arranged systematically to make them easier to analyze. This involves tabulating, coding, or summarizing information using tables, frequency distributions, or simple charts. On stage 3, data analysis means identifying trends and relationships. In this stage, statistical tools such as average, percentage, correlations, and graphs are applied to interpret the data. Data analysis transforms numbers into insights. Stage 4, decision making means choosing the best course of action. Once the data has been analyzed, the next step is to make a decision based on the findings. This stage involves interpreting the results and applying them in real-life situations. On stage 5, evaluation and feedback means assessing the results. The final stage focuses on assessing whether the decision achieved its intended goals. Evaluation uses additional data collection and analysis to measure results, identifying improvements, and inform future actions. Simplified real-life example of the DDDM framework. Imagine a small cave owner who notices fluctuating sales and wants to improve business performance. The first thing he did was data collection. The owner records daily sales, customer visits, and promotional activities for 3 months. Then, data organization. The information is arranged in tables, showing sales per day and per promotion type. And then, data analysis. The owner calculates average and finds that the sales are highest during weekends and after online advertisements. And the fourth one is decision making. Based on the data, the cave decides to increase online promotions and offer weekend discounts. On the last one, evaluation. After a month, the cave reviews results and observes a 20% sales increase, confirming the effectiveness of the decision. This simple example demonstrates how the DDDM framework uses statistics to convert raw data into a rational, evidence-based business strategy. In conclusion, statistics are the foundation of smart, evidence-based decision. The DDDM framework turns data into clear, actionable insights, useful in business, education, governments, and daily life, builds clarity, accuracy, and fairness in every decision, empowers people to make informed and confident choices. Thus, the relevance of statistics in decision-making lies in its power to bring confusion to clarity, uncertainty to structure, and confidence to choose. By embracing data-driven approach, individuals and institutions can make wiser, fairer, and more sustainable decision-making that are not merely reactive but informed, purposeful, and grounded in truth. And that's all. Thank you.